Good morning one and all. Today I am going to teach about one of the applications of 555 IC timer in monostable mode, that is missing pulse detector. Okay, this is the pin diagram for this missing pulse detector. That is, we have 8 pins. Okay, 8 pins. This 1 and 5 is shorted with a capacitor. Third pin is the output. We have a transistor where the trigger input is given. Okay, this is the waveform for the missing pulse detector. Okay, here what we are doing means whenever the input trigger is low, okay, whenever the input trigger is low, the emitter in the diode of the transistor, Q1 gets forward biased. Okay, the diode in the emitter gets, that is in the transistor, gets forward biased. So the capacitor gets, here the capacitor gets clamped. Okay, here the capacitor gets clamped to few volts, that is approximately equal to 0.7 volt. Okay, the output, now the output of the timer goes high. Okay, so the circuit is designed so that the time period of the monostable circuit is slightly greater, that is 1/3 longer. Okay, it is 1/3 longer that of the triggering pulse, like that way, such a way that it is designed, the circuit is designed. So the triggering pulse train keeps coming at the pin 2. At the pin 2 only the triggering pulse comes. Okay, at this pin only the triggering pulse comes and the output always remains high. Okay, if a pulse misses means the triggering input is high. Okay, if a pulse misses means the triggering input is high, and the transistor Q gets into the cutoff region. It goes into the cutoff region. Now the 555 timer is into a normal state of monostable operation. It is in a normal state of monostable operation. So the output of the low after time t period of the mono short. Okay, the output is low after a time period of t short. Okay, time period t. Okay, that is the mono short period. Okay, so we have studied about the missing pulse detector. This missing pulse detector is mostly used in the hospitals, that is to detect the missing pulse heart. Okay, for a heart patient we can detect the missing pulse heart. Okay, so see this waveform, we have the triggering input. Okay, this is the triggering input. Okay, this is the waveform, that is capacitor charges and discharges, charges and discharges. This is the output voltage waveform, and that is capacitor voltage waveform. This is the missed pulse. Okay, this is the missed pulse. Okay, missed pulse is obtained at the output. Like this way we are finding the missed pulse. So we have studied about the missing pulse detector using the pin diagram. Okay, we are going to study about linear ramp generator. In linear ramp generator, the resistance is replaced by constant current source. Okay, resistance is replaced by constant current source. This constant current source linearly charges the capacitor by the transistor Q3. That is, by the constant current source, with the help of transistor Q3, it linearly charges the capacitor. Okay, now the voltage at the capacitor is given by, this is the timing diagram, that is pin diagram of the linear ramp generator. We have one capacitor, another capacitor, two capacitor, that is another capacitor 0.2 microfarad. 5 is connected to the capacitor, 4 and 8 is shorted. This is the VCC power supply. Third pin is the output, second pin is given here. Okay, so now we have the output, that is capacitor voltage is given by Vc equal to 1/C integral 0 to t I dt. This equation is taken as the first equation. Okay, And here this by KVL rule, okay, by Kirchhoff's voltage rule, we can write this one as that is R1 divided by R1 plus R2 into VCC minus VBE, that is equal to beta plus 1 I into IB into RE, okay, that is equal to, that is approximately equal to, then we can take it as beta IB into RE. This one we can neglect it, okay. This one is neglected because beta is very very high, so this one is neglected. So here this IB is the base current and the IC is the collector current and RE is the emitter resistance and beta is the current amplification factor for the transistor Q3. Current amplification factor for the transistor Q3 which is very very high. So only we are neglecting this one. Okay, so this can be written as IC into RE. So we have I into RE. Okay, this is written as I into RE. So from this we can write I is equal to R1 into VCC minus VBE into R1 plus R2 divided by RE into R1 plus R2. This is the second equation. Okay, substituting 2 in the equation 1, we get VC equal to, we are substituting this 2 in 1 and after integrating we are getting VC equal to R1 VCC minus VBE into R1 plus R2 into T divided by C into RE into R1 plus R2. At a time T is equal to T, that is when small time period T is equal to capital T means the capacitor voltage becomes 2 by 3 VCC. So now we are going to substitute T is equal to capital T and the VC equal to 2 by 3 VCC. So substitute the values in this equation and compute the value for capital T. From this equation compute the value for capital T. Put VC equal to 2 by 3 VCC. Okay. So you will get T is equal to 2 by 3 VCC into RE into R1 plus R2 into C divided by R1 into VCC minus VBE into R1 plus R2. This is the total time period. Okay. Here the capacitor discharges. Okay. The capacitor discharges as soon as it reaches the voltage 2 by 3 VCC, which is the threshold of the upper comparator in the circuit. Okay. The capacitor discharges as soon as it reaches 2 by 3 VCC. The capacitor voltage remains 0 till another trigger is applied. The capacitor voltage remains 0 till another trigger is applied. So this is about linear ramp generator. That's all. Thank you.